Hey, my name is Luis Simonetti, and I'm a technical marketing engineer in Stream Networks. And I'll be actually presenting the FabricConnect architecture slides. And here to join me today, my colleague Jeff Cox. Jeff, if you want to introduce yourself.
Great, thanks, Louis. Hi, everybody. My name's Jeff Cox. I am a senior technical marketing engineer with Extreme Networks, and I will be presenting the FabricConnect in the data center section of the presentation. Back to you, Louis.
Thanks, Jeff. And here we go. So considering that we're supposed to have a limited amount of time, I think we just get straight into it. So first of all, let's talk about what is FabricConnect. So FabricConnect is a solution designed to virtualize the network infrastructure to create a resilient foundation over Ethernet on which to support all network-related services. Now, yes, it's a mouthful. Here's the thing, but why did we do it? Because a lot of customers sort of, come around and ask the question, why do we actually bother? I mean, there are plenty of solutions out there already available in the market, but we actually decided to go in a particular direction. And the direction for us, of course, is about FabricConnect. Well, it was mostly in response to customer feedback. Customers were telling us they were doing more and more on their network. And the more that they actually did on the network, the more complex it actually became. And the general comments that we were getting back was basically about the fact that, okay, complexity and reliability, normally they don't go hand in hand, and they really wanted to have some simplification of the network. And then, of course, on top of that, looking at what they were doing on a day-to-day basis, there were a lot of time basically spent doing changes and moves. And if there was some automation in place as well, it could really make a difference. So when we started to look at how we were actually deploying networks and how they were actually delivered, we thought, okay, there must be a better way of doing this. And after basically doing the same thing for over 25 years, we thought if we had a clean sheet of paper and we were actually to start again, where would we actually go? And this is where FabricConnect basically came to be. Now, keeping in mind, FabricConnect was actually not specifically designed for the data center. A lot of other solutions out there, they really were based around the data center and how to resolve specific issues into the data center. FabricConnect, it's not like that. FabricConnect was really designed as a solution, as a complete solution for a enterprise network. So for us, campus, data center, branch, all fundamentally the same sort of solution, the same infrastructure, the same solution applies. So even when you have this situation, for instance, where you have branches which are going across, for instance, an IP infrastructure with a service provider, again, for us, it's the same solution. So FabricConnect actually will span right across the entire customer infrastructure. Now, if that service provider is running IP, great, we can actually run the Fabric over the top of that IP service. And fundamentally, what it allows us to do is to extend all the services that are actually available across the FabricConnect all the way to the branch as well. So it becomes an integral part of the solution. The same sort of rules, the same sort of business policies that applied inside of the campus can apply to the branch just as easily. And of course, it makes it an integral part of that solution. Now, a little bit about FabricConnect. I'll be quick. I know that not a lot of people actually enjoy this sort of part of protocols and all that. FabricConnect is basically made up of 3 protocols, if you like. So there's the Mackie-Mac encapsulation, which is basically the 802.1ah protocol. Again, for those that are actually familiar with layer 2, this is really nothing new. You basically take a layer 2 frame and you put it inside of another layer 2 frame. But what Mackie-Mac actually did, he introduced this idea of a service identifier. And that's really the part that virtualizes the network, if you like. Now, on top of that, we actually have the ISIS protocol. It's a dynamic routing protocol. Again, for those of you that are not familiar with ISIS, think of it as the grandfather to OSPF, the very popular layer 3 routing protocol. They are very similar, as a matter of fact. The thing with ISIS, of course, it is not IP dependent, so it would actually run over a layer 2 infrastructure quite easily. And specifically, the reason why it was selected, because again, FabricConnect actually operates at layer 2 at the Ethernet level. And because of that, it's already using a well-proven infrastructure, basically using the standard Ethernet switch path. Now, the one thing that is quite different in the way that actually SPB works is in the fact that the old way of actually doing learning, which is basically the learning and flooding mechanism that layer 2 switches utilize, that's actually taken away completely because of ISIS, and the actual learning is done using the ISIS protocol instead of actually flooding. And then finally, for us to complete the solution, and again, because this is all based on layer 2, you actually have a CFM, and I always get this wrong, configuration fault management. I mean, this wishful thinking is actually connectivity fault management, which again, because you actually have a layer 2 infrastructure, you're still going to be able to actually use your standard tools to be able to troubleshoot it. So CFM comes in and allows the operators to be able to troubleshoot the actual infrastructure easily with things like layer 2 pings and layer 2 traces, right? Now, again, the whole idea is that once the fabric is actually deployed, Fabric Connect is actually deployed across the infrastructure, you don't really get to touch it pretty much ever again. All you're really doing is just putting services over the top of that infrastructure. So what kind of services can you actually run? So the kind of services that you can actually have, layer 2 services, for instance. So you can create a VLAN and attach it to a service, to a service identifier. So you'll probably hear me use the word ISID. That's fundamentally the service identifier. So here's an example where you actually have a VLAN 20 interconnected to an ISID. In my particular example there, it's a 220 ISID. And these are very common inside of data centers because it basically helps for the provisioning of applications inside of host. And of course, if you are running vMotion, where you're actually moving application from one host to the other, naturally they need to actually be on the same environment, on the same layer 2 environment, and this really makes it quite simple. Now, the key to it is that really you're only doing this sort of deployments of services at the edge of the network. So you can just go to the actual top of rack, define a service, attach it to a service identifier, and the network will take care of the rest. Now, I'm not going to get into the detail of how that particular services are created or initiated. And as a matter of fact, Jeff is probably going to touch on that in his part about the data center. But these services can be either manually configured, they can be initiated by NAC, by the Network Authentication Control, or by policy, as a matter of fact. And in some cases, they can actually be initiated by the devices themselves as they connect to the network. So how they actually initiate it, that's a separate discussion. But the fact is that the actual services themselves are just initiated at the endpoints, and the customer doesn't really have to touch the rest of the network. And of course, again, just a case of if you need to stretch those services into other parts of the network, you just go to where the service is actually needed. In this particular case, the example is actually showing just stretching that service all the way into the access layer in the campus. So once again, you just create the actual VLAN, you attach it to a service, to the ISID, and as long as the ISID is the same, basically the service just stretches right across. No need to touch the distribution, no need to touch the core, no need to touch the actual data center core switches, just the edge, nothing else. And again, because the branch is part of that same solution, if you actually need to extend that service all the way into the branch, similar situation, create the VLAN, attach it to a service, and away it goes. Now, again, this is not typically what you would actually do in a customer environment. It's not normally what a customer will do to actually stretch a layer 2 service from the data center all the way into the actual campus, although there are situations under which that's actually necessary. So another service that is actually available is actually a layer 3 service. And for a layer 3 service, what you end up actually doing is you create a virtual router, you connect it into a service, and basically wherever you need that routed environment, you just create the virtual router and connect it into the same service. Once the virtual router is created, you get to define what is redistributed inside of that service. And then you just go ahead and create your layer 2 services, give it IP addresses and of course, gateway protection protocol if that's necessary. And then again, you just go back to basically stretching your layer 2 service to the top of rack in this particular situation. So we have that VLAN 100 stretching to a top of rack server farm. And in the campus, of course, similar situation. You create your layer 2 service for the actual users, and they can connect into those services as needed. Again, they can connect by getting authenticated into those services, or by manual configuration, of course, or by policy. And this is an example that actually you see more often than not, where basically you have clients which are connecting into the campus, and they are getting routed into the data center itself. Now, probably the most exciting part of what we did with the actual with Fabric Connect is, again, we can actually stretch these services all the way to the branch in a very similar way. If I want to be able to actually take those services that are in the data center application, whatever it happens to be, all the way to the branch, similar situation. I can just create that router environment, attach it to the same service, create some redistribution, and now I can actually route across into the data center as well. Similar to what we have in the campus, no different environment, everything's still exactly the same. Same policy can be applied, so you have a consistent set of policy right through, which really helps with security, because as we know, the more you actually make the actual policy that you have the standard without having to have lots of exception for everything, the easier it is to actually deploy security. And making it simple, right? This is all about trying to make it simple. Complexity, as I said, it's the enemy of reliability. Now, where it gets really exciting is in terms of actually multicast. So we can also have multicast support inside of the actual Fabric Connect. Now, this is quite a new approach to the way that actually multicast is done. And I know that when I said the word, exciting, and I join it in with multicast, obviously that's really bringing out the geek in me, if you like. A lot of people, I'm pretty sure, that would not actually think of multicast as being exciting, quite the opposite, because more often than not, multicast actually deployments can be very challenging. And that's, to a certain degree, is because of the way that we actually have been doing it for a very long period of time. Now, the way that is actually done inside of Fabric Connect is actually quite different, if you like. So the way that it works is that when a multicast source is actually identified, the feature is actually enabled on a particular service, that multicast source and group specific, it's actually automatically given a service inside of SPB. So as you can see here in my example, I've got a service, a multicast group 239.0.0.10, and it's actually automatically assigned to a service which is actually 16,000,001. Now, that's automatically actually done. So there's no need for a rendezvous point. Arguably, you can say that basically every node inside of an SPB, inside of a Fabric Connect network, is a rendezvous point. So it's actually responsible for registering that multicast traffic. And then once a client wants to join, so we have a client there in the campus, is actually sending his IGMP, his request for joining that particular group. Once he actually sends that particular request, then he automatically will actually join that particular service, the service 16,000,001, and multicast will actually start streaming to that client. So you can see that although I actually have a layer 3 connection between the client and the actual data center, for multicast, the connection that goes from the actual source to the client is actually just a layer 2 connection. It's just a service that goes across it. So what Fabric Connect is actually doing is, for these services, every time that a service is created, it will actually generate a connectivity tree in the background, and is actually creating this connectivity tree so that it knows where the traffic is supposed to be delivered. So SPB basically is about building a lot of trees, if you like. So it builds trees for the connectivity in itself from every node to every other node. And then, of course, it builds the trees for the services. Once a service is created, it will create a tree that will determine where the actual endpoints of that service are. In this particular case, with multicast, those endpoints are dynamic. So when a client comes in and joins, then, of course, the multicast will actually start streaming because it becomes a member of that particular tree. And again, once again, similar situation. If you're in the branch and you send the request, the multicast will start streaming at layer 2 all the way to the branch. Now, again, this is quite exciting because if you think about it, right, that branch is actually connected across an IP service, across a service provider. More often than not, the service providers are completely unaware of multicast. If you do ask them to actually support multicast, chances are the answer is probably no, or it's going to be, well, it's going to cost money. But in this particular case, again, because Fabric Connect is running over the top, is masking the fact that the service provider is actually unable to provide those services, and instead is allowing the services to be able to be extended to the branch as well, just as well as into the campus. So looking into the campus itself, what are the benefits of actually running Fabric Connect all the way to the actual access itself? Well, first of all, of course, is maximum design flexibility. Now, we're no longer bound by the actual physical connectivity that we have, and we can pretty much have any kind of connectivity, and Fabric Connect will just adapt. Again, Fabric Connect is there to provide the foundation, so it will provide the loop-free environment and the actual resiliency. How you actually then build the services on top of it, it's up to the customer. And of course, you can then build the services over the top of that campus infrastructure, depending on what you actually need. But as I said, one of the key reasons that you will want to actually stretch Fabric Connect all the way to the edge is because, of course, it gives you the maximum flexibility that you can possibly have as far as topology. Now, also, by stretching the Fabric Connect all the way to the access, it means that you can actually have all the services that we just discussed, layer 2, layer 3, multicast, all the way to the access as well. And again, taking advantage of all those services all the way to the access of the campus. And also because by running Fabric Connect all the way to the actual access, it gives you the maximum flexibility in terms of virtualization. Now, again, a little bit geeky if you like. Basically, what we've done, we have virtualized the VLANs. And this is something that a lot of customers need to get their head around. Now, we are so used to using VLANs all the time that when we start talking about the virtualization of VLANs, it becomes, it's a bit of a difficult subject to cover sometimes. You got to bear in mind that VLANs at this point, when you're actually running Fabric Connect, only have meaning for the actual port in which you're connecting to, which means that now that you have the virtualization of that VLAN can be down to the port level. So it makes quite a difference. And by actually having Fabric Connect all the way to the edge, you can actually have that virtualization of that VLAN all the way to the port level. I will cover that in a little bit more depth in the next few slides. Naturally, in the campus, if you don't actually have Fabric Connect devices all the way to the actual edge, we still provide, of course, option for non-Fabric Connect access switches. And that's actually done by a protocol called Fabric Attach. Now, Fabric Attach is really supposed to be for onboarding devices at the edge. But again, we also have a solution that works in conjunction with our Exos products. And what it does, it gives you the look and feel of the Fabric Connect by allowing you to actually create VLAN and services linkage between the two without having the full protocol of the Fabric Connect, without having the ISIS, without having the MAC encapsulation. And that's actually done by using an LDP. So it's basically a discovery protocol, and fundamentally just utilizing technology that's already available and just extending basically the VLANs over a tag interface all the way to the edge. Now, arguably a drawback, but the only real catch is in the fact that if you have Fabric attached devices, then those Fabric attached devices will actually need to be dual homed into a switch cluster or a pair of switches that are actually acting as one. Also, in the industry, we normally refer to them as being an MLAG. And so that's from a topology point of view, you have a little bit less of the flexibility, although I guess the MLAG and switch clustering with access switches specifically being dual home into a core distribution, it is fairly common, right? Now, having said that, again, why do we do it? Why would you actually want to actually stretch Fabric Connect all the way into the edge? Well, because, as network architect, this is normally what we like to design. So very clean type of approach where you have your core, you have your distribution, you have your access, you have physical links dual homed into the distributions. This is how we actually like to look at networks. In reality, what you actually get, this is actually an example of a customer network that I've been working on just recently. Happens to be a college here in Australia. And again, it's quite common that network have actually evolved over a period of time. It started out that they actually had a couple of switches inside of a building. Then they started to stretch the network across other parts of the actual campus. And of course, the network grew. But as it grew, it didn't quite actually grow in the way that we would like with, dual home connections and et cetera, et cetera. It just grew. And in this particular case, the customer was having quite some problems because the only way that they could actually deploy such a solution was actually utilizing spanning tree. And I think that pretty much everybody in the industry, if you talk about spanning tree, they can probably tell you about their horror stories of some point when things didn't quite work the way that they expected, and it was way more challenging than it should have been to actually bring everything back. So by having Fabric Connect all the way to the access, you can actually turn around and substantially simplify this sort of network because, again, topology is no longer an issue. The network basically is capable of going out, discovering what is actually out there. Each node will build its own tree of connectivity from itself to everybody else, and fundamentally make sure that you have that foundation in place where then you can build your infrastructure on top of it, or all your services on top of it, without having to worry about loops, without having to worry about resiliency, without having to worry about what is the actual network going to do when I lose the root of spanning tree, for instance, which makes it substantially easier and simplifies things for customers. Now, I did mention Fabric Attach, so I think that I just want to go into a little bit of detail about it because, again, we do get a lot of questions, especially in the campus. So Fabric Attach, fundamentally, there are three elements to it. You have Fabric Attach servers, Fabric Attach proxies, and Fabric Attach clients. So let's start with the clients because it's probably the easiest. So Fabric Attach client is fundamentally any device that can actually run the protocol itself. The protocol is a standard, and the only requirement from a Fabric Attach client point of view is to be able to send in a request for their particular VLAN and service that they need to connect into. Now, a client can be pretty much anything. In our case, a client is, of course, our APs. When our wireless APs connect into our switches, they can send in the request for their service, and again, making it simpler to onboard our APs into the network, and basically facilitating that zero-touch provisioning that we often speak about. There are cameras out there that already have Fabric Attach enabled on them. There are industrial switches that have Fabric Attach enabled on them, act as clients. So there is a number of devices that are actually out there. And as I said, ultimately, Fabric Attach itself is a standard. So anybody that wants to actually deploy that particular client into the device, they can do so. Now, a proxy, an FAP actually is a device such as a switch, which is actually not running Fabric Connect in itself. What a proxy will do, it will act either on behalf of the client or for devices that are actually non-Fabric Attach capable, to then request that VLAN and that service onto the Fabric Attach server. So they're not capable of running Fabric Connect themselves, but they actually get the ability to be able to request a VLAN and an IC onto a switch which is actually capable of running Fabric Connect. And then ultimately you get to the actual Fabric Attach server. Fabric Attach server, by definition, is a device that is running Fabric Connect, and it's his responsibility to actually take that VLAN and IC request and turn it into an IC, turn it into an actual service inside of the Fabric Connect network. I know a very quick one that I've gone over it. As I said, obviously there's a difference between Fabric Attach and Fabric Connect, and the key difference there is the fact that from a Fabric Attach point of view, you can only really request VLANs and ICs, so you normally tend to actually have services which are based on VLANs only. If you have a full Fabric Connect edge, on the other hand, you can actually extend layer 3 to it. You can also extend multicast all the way to the actual edge by using Fabric Connect. On the other hand, if you actually have an FA proxy, for instance, or an FA client, then you will actually be just sending in IGMP requests to actually get that multicast. It's up to the actual Fabric Attach server to then actually be able to provide that multicast service down to the proxy or to the client. Now, and I think I mentioned it before, so it is typical to actually, for the purpose of resiliency, it's typical to actually have an MLAG or a switch cluster configured to actually provide that service, provide that resiliency to the edge. So typically what you have, it's a Fabric Attach proxy or an access switch that is actually dual homed into a pair of switches that are acting as a cluster, and therefore they're also acting as a cluster as an FA server. So that then, of course, the request for that particular service and VLAN will actually go to both of them. In the event of one of them failing, of course, the other one will take over seamlessly, and the service will already be there. So as far as the customer is concerned, the actual resiliency is all the way. and there is no loss of service in the event of a failure of a switch. Now, again, services, it's all about endpoint configuration. Once again, if a customer or a client connects into the actual edge, again, how that service is initiated, well, more often than not, it would actually be based either on a policy, which will be sent down by our Extreme Management Center, for instance, or it could be actually set by NAC. So client can actually come in and use EPOL to get authenticated onto the network. When they get their authentication reply, part of that authentication can actually be the VLAN and the IC that they actually need to connect. Once that happens, the VLAN is created, and of course, with the matching onto the IC, it will actually join that particular service. And again, if this happens across another access switch, then automatically that service will actually join together. Those two devices will be able to talk to each other. Again, in a campus scenario, if this was actually getting routed, then I can actually choose where I put my router. I can actually put it into the core, or I can put it into the actual distribution, depending on where it makes sense. And I can then route out of that service. And again, the more customers that actually they join into the service itself, the service will just be extended out to wherever is actually needed. There's no need to touch the distribution, no need to touch the cores. The service is just extended as required. Now, the interesting part about this is when it comes to security, we hear the terminology of elastic networks, if you like, or elastic services. Again, because when the customer actually leaves, where the client actually leaves, that service, if it's no longer needed on the access, is actually deleted and it goes away. Now, this is kind of interesting because, sometimes customers ask and they start talking about security. We talk about, the improvement in security that we made in terms of what we can do with Fabric Connect. And what I like to say is, there is no spoon. So whenever we actually created a service, what it really happens is you're basically opening a door. So you're putting a door in place for that service to go through. Now, the more doors you have, the more you basically have to go around and try to actually lock them all down when you're trying to actually maintain a secure environment. Naturally, the quickest thing that you can do in order to actually secure a network is to take the door away. I mean, yes, locking them is great, but if you take the door away, then there is no door to open in the first place, right? So you hear us use terminology such as elastic services or stealth networks, and that's really referring to the fact that, okay, inside of a Fabric Connect network, we are basically really limiting the number of doors that are open in the first place. So you don't have to go around and lock them because the doors are not there to start with. Now, as I was referring before, there's different type of layer 2 services that you can extend to an access. The most typical one is basically when you actually have a VLAN that is attached to an IC. And normally in a VLAN, you have lots of ports that will actually be members of that VLAN on the access, and they will actually go out on that particular service. Now, if you are running Fabric Connect all the way to the edge of the network, you also have the possibility of virtualizing that VLAN all the way to the port. Now, why is this something that you actually be interested in? Well, for instance, if you have the environment where you have multiple customers and they may want to all use the same VLAN for whatever reason. So if you are in a situation where you are in a multi-tenant kind of environment and they want to actually use the same VLAN, what you can do is that for one particular customer on that particular port, you can say VLAN 20 for that particular customer is actually attached to 220. And then on the same switch, on a different port, you can say this particular customer is also attached to VLAN 20, but his service is actually, say, 201 and 20. So now they have the same VLAN going out to their respective customers, but they're actually not on the same layer 2 service because the actual service identifier itself is different, so they will not be able to talk to each other. So we're taking the VLAN, and first of all, we virtualize it all the way out to the node, and now we're taking that VLAN and we virtualize it all the way to the port. So that you can actually differentiate different customers, same VLAN, different layer 2 services, which is quite powerful. Now, another type of layer 2 service that you can have if you're actually running Fabric Connect all the way to the edge is actually called a transparent UNI or a TUNI. And transparent UNI actually virtualizes the VLAN altogether in the sense that it really doesn't care about VLAN anymore. What you're doing is you're actually joining a port into a service, and fundamentally you're giving the opportunity for a customer to connect multiple services, multiple VLANs into a port and be able to transport it across the network to another part of the network as they need, right? You don't see that very often in enterprise. It is something that I've seen it in specific implementation where, for instance, the customer is actually acting like a pseudo service provider, if you like, and that's the sort of thing that it would actually do. Now, if you have a fabric attached access enable solution, then again, what will actually happen is the same sort of thing. The NAC or the policy will actually dictate where that customer actually lands. They authenticate, they get their VLAN and IC mapping, but instead of actually having an IC directly created where the access is, the FA proxy will generate a request towards the FA server. The VLAN is then initiated on the FA server all the way back to the actual access. So you can see in the diagram, the VLAN is actually created all the way into the actual FA server. And then it's the responsibility of the actual FA server to create that service into the Fabric Connect itself. Again, all of the flexibility minus the aggravation, if you like. Now, for layer 3 services, I mean, we tend to talk about layer 3 services a lot in the context of multi-tenants or applications separation, if you like. I like to normally think of them as being actually security zone, right? So I'm going to go back to my previous example where I was showing you my green layer 3 environment. So again, it's spanning between the data center, the campus, and all the way into the branch. And of course, now I put my layer 2 services in place so that I can actually route from the campus into my applications, into the data center. Now, just for the sake of the diagram itself, I'm showing that the green routers are actually on one side of the data center. More often than not, those routers, those VRFs will actually be across both data centers because application may move between the two. And I'm just really doing that just for trying to keep the actual the diagram clean. Now, of course, if you are in a multi-tenant situation, what you would do with your multiple tenants would be to actually create another layer 3 environment. So in this case, you can see here my orange layer 3 environment is connected to a different service identifier. And again, you then just go and create the my clicker has just stopped working for a second. You create the actual the relevant layer 2 for their services, and of course the two will be completely separate from each other. I'm having a bit of a technical issue, sorry about that. And again, you can extend it from the campus all the way into the data center and all the way into the branch. Now, again, the typical sort of thing that happens is that you can actually think of these as being, for multiple tenants, and of course they can even have overlapping IP subnet schemes if they want. Really not an issue as far as being able to support it. Now, what would you do in order to actually go between these tenants? Of course, you would actually use a firewall and with the relevant business policy that are required to actually manage the traffic between the two. Now, this is just as valid if you actually have a single tenant inside of an enterprise customer and they're actually using multiple applications. And in that particular case, an application, for instance, could be the CCTV system. So they can actually run the CCTV system in one layer 3 environment and keep their back office application in a completely separate layer 3 environment. And then they can actually decide whether or not they need to actually be able to go between it by using the firewall, which is really what the is really all about. More often than not, you'll be surprised how many times you come across the customer is saying, well, we're not very happy with the performance of the network. Over the years, it seems like the performance of the network has been slowing down. And more often than not, when you start to look into it, what you really realize is that they're not talking about the performance of the network. What they're really talking about is the performance of the firewall. Because what happens is that they tend to actually use the firewall to become the router for the network. So all the services are taken up into the firewall, they're routed by the firewall in order to basically prevent lateral movement. Now, yes, that is a solution, but unfortunately, firewalls are really not designed to actually operate in that way. And so when you start to actually have every service going to the firewall, they become the bottleneck, if you like. Now, the idea of the firewall was actually to provide security between security zones. Now, we have now the ability to be able to make those security zones, to provide those security zones, and keep multi-tenants, keeping applications separate. keep the routing inside of the actual network for those applications, for those tenants, and then basically just have the firewall doing what they're supposed to be doing, which is actually to be able to route between security zone itself. Just want to give you a bit of an example. I mean, this is actually a design that was implemented by a customer. This happens to be in India. I know a pretty busy network. This was actually designed the way that we would have liked. So you can see at the bottom, we actually have the campus and the data and the access layer. And then we actually have the data center. And of course, for them, when we first came across them, the challenge was the fact that they had lots of filters right across the actual cores and distributions in order to prevent that lateral movement. What we ended up doing for them was actually we designed multiple layer 3 environment. And one of the requirements that they had was, for instance, they were actually acting like a pseudo service provider, taking users inside of their environment out to the internet. So the very first service that was created was precisely for that. So there was a red layer 3 service, if you like, that was created to take users out to the internet. And then, of course, they had their own backend services that they needed to have created. So that was another layer 3 service on top of that, and it was going out to the firewall. And for them, as a matter of fact, I think we actually ended up creating a total of about 5 layer 3 environment. Again, not so much multi-tenancy, just a case of, having a look at what applications are available, what security is needed between the application, and be able to provide that separation between the applications with very minimal configuration. Again, all of this can be done basically by just configuring the endpoints, right? And of course, you can see here that the data center, it's an integral part of what it is that we do. So the fabric extending all the way into the access, as I mentioned, a lot of benefits for doing that. It extends the services all the way to the access. It enables greater level of flexibility with the topology. But by the same token, this solution works very well when it's actually in conjunction with the data center itself. So I think that on that note, and considering that I just realized that I've taken a lot of time to actually get to this point, I'm gonna leave it to Jeff. He never got a chance to actually even ask a question, but I'm gonna leave it to Jeff, and he's actually going to take you through the data center part of it. Jeff.
Thanks, Louis. As Louis mentioned, we're going to switch gears here and talk about the Fabric Connect data center. In particular, we're going to talk about distributed virtual routing. So why Fabric Connect in the data center? First, it gives you flexible topology options. So unlike some of the modern data center network topologies, such as a 3-stage or a 5-stage design, Fabric Connect, you can connect Fabric Connect nodes in the data center in any desired topology. We don't restrict how customers connect their data center nodes together. Okay, and at the leaf layer, we can cluster, whether it's clustered or non-clustered. The leaf nodes can be directly connected together, so we can optimize east-west traffic. If you have virtual machines that are on adjacent switches, they can use that direct link connecting the leaf nodes together. Seamless extension of services from the campus to the top of the rack. Louis talked about the campus services, Fabric Attach, layer 2, layer 3. They can be seamlessly extended all the way to the top of the rack in the data center. So there's no need to run a separate data center technology in the data center. Fabric Connect in the data center also optimizes traffic flows within the data center. So your east-west traffic between adjacent top of racks, since there's a direct link between them, we can utilize that link. We don't have to go to the core to route traffic between adjacent virtual machines. Traffic outgoing from the data center, so the south to north traffic, we optimize using Fabric Connect and DVR, and as well as incoming into the data center. And we'll get into more of how we do that with Fabric Connect. So. East-West data center East-West challenges. So it was about 10, 15 years ago. Most traffic in the data center was south to north, right? It was just exiting the data center. But nowadays, with the advent and proliferation of VMware virtual machines, we've seen an increase in the amount of East-West traffic in today's data centers, where it's almost becoming dominant within the data center. So any optimal data center design has to maximize east-west data bandwidth, as well as minimize the latency, okay, of east-west traffic. Okay, so with in this the spine leaf architecture in the diagram here, which is a traditional one, a 3-tier, you have your top of rack layer, which is layer 2 only, and then you have your spine layer, which is just an aggregation point for all of your leaf nodes, and then your border leaf layer, which is doing all of your routing. Okay, so that is a traditional leaf spine network. So if you wanted to optimize east-west traffic in this scenario, you would have to add capacity at both the spine layer in order to increase the east-west traffic, because there are no links between the leaf node, the access layer nodes. So as far as and with traditional Ethernet fabrics such as Trill, we can optimize layer 2 east-west flows. Okay, so if, as you can see in the diagram, if the virtual machine is within the same access switch, obviously it stays within that switch. If it is if the virtual machine originates on different access layer switches, then it would have to go down to the spine layer. So we can optimize layer 2 east-west traffic. But as far as layer 3 east-west flows, since the top of rack is just layer 2 only, all the routed traffic has to go down to the border leaf layer and get routed back up to the top of rack layer. So very inefficient routing with traditional data center networks.
And so I believe this is kind of a typical, sorry, Jeff, I was just going to say, this is kind of a typical sort of scenario where you're actually having virtual machines actually using shared storage or anything that is basically shared across the actual data center. Normally they end up on different subnets, right? So you would actually have to route to that shared storage, or you would have to route to that shared database all the time that you actually, whenever you're doing something with those resources, right?
Right, good point. Okay, what is DVR? So DVR is a Fabric Connect feature which optimizes layer 2 and layer 3 data center traffic in a simple and scalable fashion. So don't think of DVR as a separate data center technology. The nodes, it's a Fabric Connect feature, so the nodes in the data center are still running Fabric Connect, so they're still running the ISIS protocol as the control plane. They're still running the MAC and MAC encapsulation for the data plane. So it's just, think of DVR as just a data center feature for Fabric Connect. What are the benefits of DVR? It provides IP gateway redundancy. Okay, so it'll at the leaf layer, it'll provide gateway redundancy in the data center, and as we'll talk about, it provides host-based IP routing within the DVR domain. So what happens? We push the routing intelligence out to the top of rack or the leaf layer, so the leaf can make intelligent routing decisions within the data center. Okay, DVR introduces an anycast gateway on the top of rack switches. So as I mentioned, the leaf switches, the top of racks become the default gateway for the virtual machine segments. Okay, simplified leaf configuration. So when we configure, we're not going to talk too much about configuration in DVR, but basically when you roll out DVR, it consists of a controller node and a leaf node, and the leaf node is obviously the top of rack, and most of your configuration is done on the controller. Okay, so all of your VLAN and IP information is configured on the controller, and that information gets intelligently pushed out to the leaves. So there's very little configuration you need to do on the leaf nodes. All the configuration is done on the controller side. And as I mentioned, optimizes layer 2 and layer 3 traffic flows. So the north to south, south to north traffic tromboning, and we'll get into that, how it does that, as well as east-west layer 2 and layer 3 traffic. So what I'd like to do is I'd like to frame this into the context of what what are the problems that DVR solves? So problem number one, so here we have before we had DVR, this would be a typical Fabric Connect data center network. Data center A, data center B, all the nodes are running Fabric Connect. And since the top of racks typically in those days when we didn't have DVR, they were just strict layer 2 nodes. So we would be routing at the core layer and running VRRP. So here we have a virtual machine in data center B, but the VRRP master is in data center A. So what happens there is the virtual machine would ARP for its default gateway, 192.168.20.1, and the master would respond, and the traffic would get routed through data center B over to data center A and out data center A. So it actually trombones over to data center A to exit data center A data center. So this is very inefficient. Obviously, any traffic that originates in data center B, we want to exit in data center B. Okay, so how does DVR solve it? So here you can see now we're running DVR in the data center A, data center B. So here you can see we have a typical 2 data center deployment, and we, as I mentioned, we have defined 2 of the core nodes as controllers, 2 in data center A and 2 data center B, and we have our leaf nodes, okay, that are actually the top of the rack nodes in both data center A and data center B. And the way it works is, as I mentioned, you configure your IP subnets and your VLAN information on the controllers, and basically the controllers push all that IP intelligence out to the leaf nodes automatically. Okay, so the leaf nodes act as the Anycast gateway for the attached virtual machine. So basically, they're the default gateway for the attached virtual machine. So when the virtual machine ARPs for its default gateway, the top of rack or the DVR leaf will actually respond on behalf of the controllers. Okay, so what does that mean? So that means that the leaf nodes are they're learning, in addition to responding to the ARP request, they're also learning the host, the VMware host IP and the MAC address. Okay, so they're learning that information. They're learning the host routes of all of the attached virtual machines within data center A and data center B. So what does that mean? So that means that they're able to make intelligent routing decisions of the ingress traffic from the virtual machines. In addition, so every DVR leaf node also holds a default route, okay, pointing to each one of their DVR controllers. So you can see the virtual machine in data center B, it would have a default route for each one of its controllers in data center B. So the way it works is that what that means is when the virtual machine data center B has traffic to send, it's no longer going to trombone over to data center A. Since it has a default route pointing to its local controller, it's going to exit out of the data center locally and not trombone over to data center A.
And that fundamentally resolves or at least optimizes the north-south traffic, right? Because of course now you can basically just exit from the closest core that you have available to you instead of actually jumping across between data centers, right?
Right. Yep. Absolutely. Okay. Problem 2. If we did not have DVR, so here same thing. Fabric Connect deployed data center A, data center B, and we are running VRRP. So once again, you can see we have virtual machine blue and virtual machine green. They want to communicate since they're an adjacent top of rack nodes, but since we are routing in the core, all of the traffic has to be routed by the core node at data center A, even though we have a direct link between the top of rack switches. Since they're strictly layer 2 switches, all of the traffic has to be routed through the core nodes. So very suboptimal routing of east-west traffic. So how does DVR solve it? So once again, we have data center A, data center B. As I mentioned earlier, the DVR leaf nodes all have routing intelligence, so they know the default gateway IP address of the attached segments. So when a virtual machine ARPs for its default gateway, it knows about the host IP address of the virtual machine and the MAC address. So every DVR node is aware of the host IP of directly connected hosts. And what happens is they share that information to all other nodes within the data center. So every node in the data center has the same exact picture or the same host IP routing information within the data center. So basically, now when the virtual machine blue has to communicate with the virtual machine green across subnets, because the DVR leaf has the host routing information for both of those virtual machines, it can utilize that direct link between the DVR leaf nodes. Okay, so it doesn't have to trombone. It doesn't have to trombone all the way down to the core and get routed back up just to be routed to an adjacent DVR leaf node. So much more efficient use of east-west traffic.
And as a matter of fact, Jeff, even if the leaf actually didn't have the link between them, because the routing is actually getting done by the leaf itself, it would only have to go up to the middle layer and be able to route across. It doesn't have to go all the way into the core, because again, the routing in itself is actually done by the leaf, not by the actual by the core switches.
That's correct.
And it's done based on the host address, right?
Yeah, absolutely. Okay, problem number 3. So we're talking about traffic coming into the data center now. So typically, what you'll see in data center designs, that didn't, before we were running DVR, is the core nodes, they would advertise just a subnet route out to the branch or the rest of the campus. So here you can see we have both data center A, data center B are advertising a subnet route 192.168.20/24 out to a branch IP router. So what the router is going to do when it has traffic to send to a host on that subnet, it's going to do an IP lookup, and it's going to send the traffic to the data center that's closest to this particular IP router, or the least cost path, basically, to the data center. So here you can see in this particular case, even though the destination host is in data center A, it's going to route it to data center B because that's the least cost path for that particular route. So it's very inefficient. So it routes the traffic to data center B over the WAN, and then it'll have to end up routing it back out the WAN to switch it back over to data center A to reach the ultimate destination. So that's the classic north to south tromboning problem. So that's very inefficient use of WAN resources. So how does DVR solve it? So do you have a question, Louis?
No, I was going to say is actually when you look at it, a lot of people sort of may look at that and think, that's an odd case, right? But you'd be surprised how many customers out there actually have this issue in their network today. That's how the actual because again, campus devices don't really know where the actual virtual machines are inside of the data center, and because of vMotion, you can just basically move the actual applications into any hypervisor. So it is actually quite common that you end up in a situation that you're actually routing traffic into one data center and then to an application, but the application just happens to be in the other data center, and then of course you have to reroute accordingly.
Right. Good point. So how does DVR solve it? So as I mentioned, within the data center A or B, the controllers have all the host route information of all of the attached virtual machines within each data center. So what they do is they just advertise. You have the option of advertising those specific host routes into the campus or into the WAN. So now when that branch IP router wants to make a routing decision to 192.168.20.10, he's got the specific host route for that particular host. So now it gets routed directly to data center A because that's where that host resides. So I no longer have to trombone through data center B to get to my destination host. So very much more efficient use of WAN resources by advertising the host route out to the rest of the campus or the WAN. So I'd like to take a quick point here and talk about endpoint tracking. Endpoint tracking is actually a new feature that came out in VOS release 8.1. Okay, and what is endpoint tracking? In a nutshell, it allows for dynamic virtual machine, basically attachment and provisioning. So Louis talked about service provisioning and service automation at the campus via Fabric Attach. So in a similar way, we have the same type of service attachment in the data center with endpoint tracking. So basically, in a nutshell, what it does, it allows the the ability for a virtual machine when it moves, basically to dynamically, at the destination host, it allows it to dynamically allocate the service provisioning information, and in particular, what the VLAN and ISID is for that particular virtual machine. So the user doesn't have to pre-provision that in the switch. It all happens dynamically. And what happens is it uses a combination of things. It uses, within XMC and Extreme Control, it uses the Extreme Connect API to communicate with VMware, ESXi, and Hyper-V. So in a nutshell, the way it works, when the virtual machine moves and the virtual machine, arrives at the new switch port, the new leaf node, essentially, the switch will detect the virtual machine. Basically, it'll detect the MAC address of the virtual machine, and it'll send a radius request to Extreme Control, and then Extreme Control via the Extreme Connect API will query vCenter server for the correct port group and the VLAN ISID mapping for that particular virtual machine. And then what will happen is the Extreme Control will push those VLAN ISID bindings down to the DVR leaf node and will dynamically provision that port for those VLAN ISID mappings. So think of it as MAC authentication for virtual machines. It's done in a secure way. There's very little user intervention that's needed. It all happens dynamically once that virtual machine moves.
I like to think of it as the follow me feature, if you like, is basically you have, when a VM moves inside of the data center, the actual service that is associated with that VM will actually follow that virtual machine as he moves across.
Yeah.
So it's the follow me kind of feature inside of the data center. And again, just bringing automation into the data center in a kind of a similar way that we have automation in the campus, with actually having, as I was saying, either policy or NAC to authenticate users into the actual campus and creating those services on demand as they connect.
Yeah,
and on that note, I think we're well and truly over our time slot. But thank you very much for your patience and for listening. And I hope that this was actually useful to everybody.
Yep. Thank you, everybody.
So
thanks for
goodbye
watching.
from Sydney.
And I hope everyone enjoyed it. And thanks for watching. Bye-bye.